Okay, I think I exist now. I'll never understand people calling their cats fur babies and similar. It feels a bit degrading to everyone involved, including the cat. Wait, why is it degrading? I'm confused. Okay. Why are these so early? Why are these lectures way too early in the morning? It's as if they lack any kind of agency like a baby? I guess, but I mean, I think it's an endearing term. Can you use that for like human children as well? Like, oh, it's my babies. Okay. Wow, I am tired. I feel very, very out of it. Skin baby for human children? Oh my goodness. Why does the word skin sound so gross? It's pretty weird. Okay, where are we? What's going on? I'm gonna open Unity. That's probably a good start. Should open the assignments. There we go. Okay. If you're here and you're one of my students, react in the Discord to that message. Show your presence. Do we have fewer people today than usual? Everyone's sleeping. Okay. Maybe I missed that it's today since nothing's on the schedule and are sleeping in. Maybe I've been trying to ping a lot to make sure that people are up to speed. But I guess if you're following teams directly, then you might miss that. Anyway, still possible to watch this after the fact, I suppose. If you want the solutions to the assignments. How did the assignments go? How did it go? Were they too easy, too hard, good balance, or what was it like? And did any of you do all of them? Well balanced. Okay, good. You did all of them? Hell yeah. Okay, should I verify that? Or should I just trust? I don't know if I did the spherical sector properly, but other than that, pretty balanced. Right, okay. All except turret yaw, then Anton came with the cheat codes. Gotcha. Yeah, the turret yaw thing is like, it's a one-liner. And so it's like, once you see the answer, it's really hard to unsee it. Okay, but if two of you did all of the assignments, then that's the cat ear requirement. So you did it. Okay, cool. Neat. I don't even have Photoshop open. I should do that. All right. Okay. All right, so should we just straight up go through all of the assignments? I think we have time to go through all of them before lunch. So maybe it's better to just do that. Some of these are a little bit easier than others. So doing the inner radius and the spherical trigger is relatively easy. So that's not going to take too long. So I think we can do all of these before lunch. And as usual, just feel free to ask questions at any time. If I'm not explaining anything correctly or if something is unclear, then do let me know. Okay, there's Toast. Toasty boy. Hey. Hello. Hey, what? I'm gonna go through some assignments. What you doing? Mr. Toast. Mr. Toast. You're standing on my armrest. Hey. What's up? What? Okay. Well. Okay, Toast. Okay. Okay. All right, that's what Toast wanted to add. I hope it helps. Let's keep Toast in the background. Impossibly charming tail. His tail is so big. It's actually pretty wild. All right. So the first assignment is to add an inner radius to the trigger. And like we talked about before, when making like mathematically defined triggers like this, especially ones that have like hard boundaries, the easiest way to do that is generally to think about them as separate tests. We have the vertical test to cut this off, to be limited to a specific height range. Then we have the angular test to make it an angular pi. And then we have the radial test to test the distance out from the center. And that's how we make the cylinder shape. So in order for us to add the minimum distance, all we really need to do is add another condition for the radial test. But instead of, but in this case, instead of being less than some value, it has to be greater than some value. And that allows us to add, an inner radius like this that we can configure. Yeah, so that's the inner radius. So let's do that. We have our trigger. It's a little bit misaligned. Maybe we should move it. Okay. Let's go to our trigger. Maybe it shouldn't be called a wedge trigger anymore. Maybe that's a little bit weird. Messed up sleep again? Oh no. Aren't you in like a really, like, you're in India, aren't you? At least in the India time zone. I have no idea. Like, what are your hours for this? Do you have to like stay awake all night? made a new script called generic trigger. Yeah, maybe it's best to rename this one. Math detection zone. It detects math. Okay. All right. So we need to add an inner radius. Maybe we should rename this. Let's rename this to what do we call this? Math trigger. There we go. Okay, there we go. Just committing that change because I want to be able to see the changes we make. All right. So I'm going to rename the radius because now this is a specific radius. They're not. It's probably good to be clear about this when you have two radii. It's good to make sure that it's like specifically you have the inner radius and the outer radius instead of just inner radius and then some thing called radius, right? So it's always good to make that clear. So I'm gonna rename this to outer radius. So outer or radius outer. In Unity, you might want to add an attribute called formerly serialized as, because when you rename variables, you might lose the data in that because it now has a different name. So if you add this attribute, all of the stuff that you've configured is still going to stay because now it knows that this was the previous name and now this is the current name. And then we're now going to add an inner radius. So there we go. Okay. I really need tea. I think it might be too warm. Okay. So now that we have an inner radius, we should probably start with drawing this. So we're going to go to our gizmos function. And let's see, what does it look like right now? So we have effectively, so 1, 2, 3 separate things. We have the lines going out from the center. We have the arcs and we have the vertical lines. So we're going to have to double up on the vertical lines and the arcs because we're now going to have to add the inner arcs. So let's do that. So now these variables v left and v right, they kind of specifically, they are the vectors pointing from the center out to this edge. So we might want to clarify that. So maybe this is going to be v left outer, and this is going to be v right outer. And then we do the same thing for the inner ones. So I'm going to now add these are the directions, I believe. I think these are normalized. So we're just going to replace these. There we go. And then we do inner. Toast. Buddy. Okay. So now these are going to correspond to the inner radius, and let's now draw our lines here. So gizmos.drawArray, instead of drawing it from the center, we're going to draw it from the inner radius on both of these. And then Why is Unity losing its mind from me using the handles class? It should be fine. Are you including the Unity editor up here? Oh wait, there are some spoilers here. I think. Yeah. No spoilers. Right, so this should be draw a line because it's no longer... We're using a start point and an end point instead of a start and a relative vector. Oh, writer just hasn't... Okay. There should be a way to clear the cache in writer. I forget how that works. It looks like it somehow lost the reference. Okay, there we go. So now we have the inner radius, and we can see that the lines now adapt to that, but not the top lines. So let's do the top lines too. So I believe let's see. So swap those with draw a line, and then we do top plus v left inner, top plus v right inner. And then since it's draw a line, we need to add top to that one too, just to do the top side. And there we go. So now we have our inner radius, at the very least on these lines. And then we do the same thing for the arcs. So here's our arcs. We have the bottom arc and the top arc. Let's just duplicate that. And then let's see, what are the parameters? We have the center and the normal and then from. Right, so I think all we need to do is swap out these with the inner ones. And so there we go. Vertical line is a little bit incorrect now, so might want to move that. That was this one. So now we're gonna do v left inner to top and v right inner to top. Although top plus that, I believe. And we have our little, I don't even know what shape this is. It's an annulus ring, but it's a prism. I don't know what that's called. Anyway, inner radius, outer radius. Square macaroni? Sure. Donut bite. Okay. But now we still haven't done the actual test. It's still counting the this target as inside over here, which is not good. We don't want that to happen. Actually, maybe I'll... So I set up a repository with this project. I could make it so that I make separate commits for individual changes, and then you can look at the history of the project if you want to see how I made specific changes. Would that be useful? Because then you can look at like, oh, this is the commit that changed this to that, and then you can see the diff of like what code changed. Okay, I'm just gonna stage these separately. Okay. That would be wonderful. Okay, cool. Doesn't take much extra work. Just wondered if you want that, because then I can do that. Okay, so now the only other thing we need to do is to add another check to our contains check here. And we did a distance test here. We had our flat distance. Remember, because we wanted to check a cylinder and not a sphere, we had to check the projected distance flat along that plane. Please remind me to drink. I think my voice is I've lost my voice because I've been talking a lot these past few days. I did a Blender stream yesterday, so I streamed yesterday too. Okay. Wait, why does this say angular check? Oh wait, because that is the angular check. We just did the flat distance up here. Right, okay. It's the goopy mushroom's fault? That's true, yes. Okay, so we want to check, is the distance greater than the outer radius? But then, because this is, if it's greater than, we return false, because that means it's outside. So then we need to do a similar thing. If the flat distance is less than the inner radius, then that should also return false, because now it's too close to the center of the trigger. And so this should be the only change we need to make to the logic of the trigger itself. And this is why I usually mention that drawing the gizmo is harder than just doing the trigger. Although that didn't seem to work. Okay, so why did that not work? Oh, because it should be or, not and. Okay. Oops. There we go. So now, seems to work. It's going inside and outside. And we can change the inner radius. We can see that it now passes. And there we go. All right. And it makes sense to have an inner radius for a turret like this one, right? Like, if something is standing closer than the barrel of this turret, you probably don't want it to be able to fire at something that's that close, right? So it can be useful to have an inner radius sometimes. Okay. All right. Let's see. That was the refactor. That is spoilers. This was the change. Okay. Just gonna commit that. So this was the added inner radius. There we go. All right. That was the first assignment. We did it. Trigger inner radius. Okay. Any questions? Just let me know at any time. Got caught up trying to fix the arc, didn't quite catch how the actual trigger was fixed. So in the contains check, we have the flat distance here. And so what we want is to check this distance if it's closer than the inner radius. And if so, we should return false, because then it's outside the cylinder. That's the logical test. Okay. Cool. Now we're going to do something fancy. We're going to create an enum to swap between different types of triggers on this trigger script. So previously we've been doing the cylindrical sector, but we're now going to make it so that you can make a spherical trigger and a spherical sector, which is basically like a cone but with a rounded cap. And so let's add that. So let's make an enum. I quite often, somewhat maybe controversially, call this type sometimes. This name is already in use by like system.type, but generally it makes it fine because this is basically a math trigger dot type. So it's kind of contained within the math trigger. So sometimes I usually define like types of a thing like this, personal preference. And so we have the 3 different types. So cylindrical sector is the current one. Could call it mode as well. You know what? We could call it shape even, because that's kind of what we're setting, right? Cylindrical sector, and then we have spherical and spherical sector. All right, then we need to add it. That should probably be one of the first things you set. Usually when I make these, when I set up properties, I try to set them up in the order that you would want to configure them. So you generally don't want to configure these things before you configure the shape. And so usually I put the shape first, just as a user experience type of thing. Okay. So that should give us a little enum pop-up. So now we have shape. Now we can set 3 different shapes, and they do literally nothing right now. So let's implement the spherical one first. Okay. So here's where we might want to split the code up a little bit. Depending on how we want to structure this, we could separate these things out into another function to like test if you're inside a test if you're inside each of these things in separate functions. It's kind of up to you how you want to structure this. I think I would split this out instead of doing if statements directly here. Some of them might share some functions. Yeah, and so I renamed contains to wedge contains. Valid, yeah. So we could do that. I think that makes sense. So maybe we want our, I think all of the functions that we're gonna do, I think all of them would make it, would benefit from being in local space, except maybe the spherical trigger. The spherical trigger has no orientation. That's the only one where doing it in local space is actually not going to matter. No, actually, the only one where it does matter is this wedge, now that I think about it. Okay, yeah, then we can keep the vector transformation stuff in the wedge. And so let's do a separate function. Okay. So what was our enum? Shape? Or wait, is it switch shape? I forget the syntax. It's a shape switch. I want to make a switch expression, but I only do them like once a month, and then okay, guess we can do this. Okay, so case cylindrical sector. Let's rename this wedge because that's the term we've been using. Yeah, I wanted to use the switch expression, not the switch statement. Okay. Has to be a way to... Yeah, there we go. This is the one that I wanted to use. Okay, there we go. So it's shape, switch, open bracket. I thought I did that, and then it just didn't work. I think I maybe forgot the semicolon. Okay, now I'm gonna shorten it even more. Not like that. That's not what I wanted to do. There we go. Beautiful. Cool, so we have our wedge contains, and now we need to add another shape. So we're going to do shape.spherical. Sphere contains. Okay, this one is pretty straightforward. For the sphere, then all we need to check is the distance. And again, if we want to optimize, we could use the squared distance. So kind of up to you which one you want to use. Let's see, where's our target? Right, position is target, and transformed position is the trigger itself, right? So we're going to need that. So we're just going to do float distance. Then we get the magnitude. I guess we can do the, use the function to be descriptive. Distance between transformed position and position. Line 61 is equals arrow. The method line is a return statement. Yeah, so if you make one-liner functions, you can use something called an expression-bodied member. And that is this arrow right here. So if you want to make a function like this is a function that returns true if it's less than 2. So usually you would write it like this, right? But since this one is just containing a single line, you can reduce it to an expression-bodied member, which has this arrow right here. It has an implicit return. You can also use functions that don't return anything with expression-bodied members. You can do the same thing for properties. So, I don't know. If you have a thing returning the area of something. What does implicit return mean? I just mean implicit in the sense that you don't have to type return. It's implicitly added by the compiler. Okay, here's a dumb example. So if you have a property where you have some sort of thing where you can get a thing or set a thing, this too you can also change to expression bodies because both of these are one-liners, right? So both of these you can just turn into expression bodies. And now it's a little bit more readable, right? And if it's only got a getter, you can simplify it even more and just do this. Which is kind of useful every time you want to add like short little simple functions. I think we already used some of them here. So these are properties with a single getter that calculates and returns this thing, right? In this case, it's the field of view in radians and the angular threshold we use for our dot product test. Okay. Right, so we have our distance. So return distance is, it has to be greater than or equal to the inner radius, and it has to be less than or equal to the outer radius. I guess I can do that. Okay. And that's kind of it. That's the whole sphere contains function. But then we also need to draw it, right? So we might want to do separate drawing functions as well. So we're going to draw the wedge. Let's see, we can keep the matrix and the color. We're going to need that for all of them. Okay. So if it's a wedge, draw the wedge gizmo. Draw a sphere gizmo. Yeah. I wish I could play music. I'm so used to playing music when streaming and doing all of this stuff. Oh yeah, this is not a... So much boilerplate for these switch statements. I don't like them. Okay. Like this would be shorter with if statements. Sphere gizmo. This is pretty easy. We just draw two spheres, basically. So gizmos dot draw sphere, or draw wire sphere. Center is at 0, and then we draw it at a radius of the inner radius. Then we do the same thing, but for the outer radius. That should be it for our spherical trigger, I believe. So this looks correct. Let's see if we can move the target. That seems to work. It's a little hard to tell the boundary of the spherical trigger, but I think it's working. And then it's outside there too. So inside, outside, inside, outside. We did it. Okay, let's see if we can switch shape. So wedge, outside, inside, outside. Okay. We got 2 trigger types down. Added spherical trigger. Okay. Do you still have the link to that repository? Let's see, there it is. Okay. If you need the repository and look at the code that I'm writing, you should be able to see it all there. I can make sure to push so that you have the code there. If you want to look at specific changes I just made, then they should show up over there. Yeah. I think if you want to look at specific commits, you can do that here. And then you can click them, and then you can see like what changed in this commit, and then it'll show you a diff of like what code was added, what code was removed, and so forth. Okay. So we have one more trigger. Let's see. The one we have left is the spherical sector. Now the spherical sector is, where is it? Is basically this shape right here. It's like a cone with a rounded cap, but we're also gonna have an inner radius to this one, right? So this is the next trigger. Okay. Maybe what's a better name? Can we call it cone? Maybe cone is better. It's a better vibe. It feels better for what this is. Okay. Let's see. So maybe we should start by drawing it. Draw a cone gizmo. Okay. So how do we want to draw this one? I'm thinking there are a few elements we're gonna have to draw here, I think. Just to get a sense of what we're gonna do. I need to drink. Okay, so the cone one is a little bit wonky because I need to drink water. Listen to my voice. It's just like dying. Why? It's probably because it's early in the morning and it's just oh, sorry. Thanks. Throwing me this error. Oh, that's just a warning. That's fine. You don't have to worry about that warning. It's just because you're not handling the default case, as in you don't have this one, and then you're gonna get a warning here. So it kind of wants you to handle all of the different enum cases, and so usually you would want to add some sort of fallback. So this underscore is basically the fallback case. If none of the other cases go through, this underscore is gonna go through. But I wrote in all three. It's because the enum could contain any value. So you could throw in invalid data even though you cover all three use cases. Yeah. So you could, I think you would throw I thought it was I guess maybe invalid enum argument exception would be good. I thought there was like enum out of range. I guess you could throw an index out of range exception. Yeah, just as long as you handle that case. Can we not use the same switch expression we used for contains while using draw? No, because this one, the switch expression has to return a value. It's not just running the code, it's returning something. So that's what the switch expressions do. Yeah. And so if you run it in the drawing code, it's not going to work because you're not returning something here, right? So I have to make this whole boilerplate because I'm returning void? Pretty much, yeah. Or you can just use if statements. If shape equals shape.wedge, draw wedge gizmo, and so forth. Scam. It is a scam, yeah. Okay, so with our cone, we're gonna have this situation where we probably want to draw some sort of cross for the part that it's aiming at, right? Like along the outer radius. And then we do something similar for the inner radius, where we draw this little cone cross. And then we might want to draw a circle around that to show the shape of the cone. And then probably connect the lines. Something like that. I think this is our goal. This is what we would want to draw for this gizmo, right? Um, okay, maybe the center line, just to give it a direction as well. I think that would be good. Yeah, kind of like that. Except that one doesn't have the circles, but it has the rest. And a few little extra bits and bobs. Neat. Batman signal light? That's a... I guess that's the shape, yeah. Spotlight shape. Alright. Where do we start? I guess we can start with these arcs, because we already have them. Like, we use those for... we use those for the wedge, right? So we're going to do something similar there. So we're using the wire arcs. We could just straight up copy those. So let's see, which ones are we going to need? We don't need the one at the top. So I'm just going to slap these in. Make our own superhero. Nice. Wait, I feel like I'm confused. Is it really supposed to be V left outer, or... Oh yeah, it's just left because we have the angle in degrees. That's why. Okay. That's why. Because you specify start vector, and then you give it a degree for how far it should extend. Okay, that makes sense. Alright, so now we need V left outer. Probably gonna need all of these, I imagine. We're just gonna steal all this code. Alright. Right, we're still throwing an index out of range exception. That's probably not great. Let's create a function for our cone contains. We're gonna do the gizmo first. Okay. So draw cone gizmo. We're doing that there. Perfect. Neat. We have some lines. We have these beautiful lines. All right. We might want to use a different radius or angle for this one, just to make it a little bit more cone-like. This red is kind of hard to see though. Maybe I'll override the visibility state for now. Actually, let's just make the contains function return true. That's white. Okay, a little bit better. Okay. What do we do next? So next we need to draw the lines on the edge and possibly the center line too. So where's our... Let's collapse a few things. We have too many things open. Cone gizmo. So now we want to draw the lines. We could probably just copy those from the wedge. So those were these lines, I believe. There we go. And then we need to draw then we want to draw the vertical version of this. And I'm trying to figure out if I should do it the fancy way or if I should just do it the manual way. What do you think? Should I do it the fancy way or the manual way? I'm actually not even sure if the fancy way is going to work, and I might mess it up. But it should be possible. Fancy way then. Oh god. I feel like the pressure is on. What if I mess it up? Actually, I don't know if gizmos have... I don't know if gizmos have that function that I wanted to have. So the thing we can do is that we basically want to draw the same shape, but we want to draw it rotated. And so what we can do is we can turn this into a function, and then we just draw it with different matrices, right? Because we don't have to like define the coordinates vertically and everything. All we need to do is rotate it. And then we're basically going to draw the same shape, but vertical. But the annoying thing is that I don't think there is a... there aren't features for pushing and popping matrices, and I haven't done matrix composition for a long time, and I might mess that up. But maybe that's okay. If you're okay with me making mistakes, then maybe that's fine. Okay. Let's make a local function. Draw a flat wedge. Just going to move these into the local function. And then we're going to draw it using the regular one. And then we want to rotate it. Okay, let's see if we can do this. Where's the matrix? It is, I guess we're doing both gizmos and handles, which is kind of gross. So gizmos.matrix equals handles. What? Handles.matrix equals m. Just so we can set the matrix for both of them. Because we did that here, right? Just adding a helper function to do both of those in one fell swoop. So we're going to replace this with set gizmo matrix. All right. And then we want to cache the previous matrix. So that's going to be gizmos.matrix, and then we want to edit it, and then we want to draw it, and then we want to reset it. So basically here, we want to temporarily modify the matrix, basically. So, and then draw the rotated gizmo. And so basically what we're doing is that we're saving the current matrix, in other words, the location we're drawing in. And then we want to modify it, then we want to draw our flat wedge again, so that's going to be this. And then we reset it to its previous state in case we want to draw other things after this, right? In the original space. So I think this should work. I think all we need to do here, if I got this right, would be set gizmo matrix. We get the current matrix, and then we multiply that by matrix 4x4.trs. So this is translate, rotate, scale. So I'm gonna just do, we don't need to have any translation, so we're just gonna pass in default. We do need an orientation, and scale should just be 1. So for orientation, we're gonna do quaternion. We can use Euler in this case. And we want to rotate it around the local z-axis, right? 90 degrees. So we're going to pass 90 into z. And so I think by multiplying the matrices like this, I believe we are combining these two transformations. I might have the order wrong. I might need to move this to the left. But I think this should work. I could be wrong. Then it's going to fail spectacularly, but we'll see. Oh, it worked. Okay. Yeah, so there we go. Now we just reuse the same function for the wedge. And then we did it. Yeah. Okay. Isn't this the 4-way axe? Well, this could be... oh, the chopped firewood? Yes. So in a lot of the like procedural drawing that I do, like I showed you my spline video earlier, like all of that is drawn in Unity. All of that is drawn using methods like this, where like I move the current drawing position and rotate the drawing position and so forth, until it is where I want it to be, and then I can reuse methods that I've used before. Usually this type of thing, where you cache the state of something and then reset it afterwards. Usually that is a concept called like pushing and popping, which is a super, super useful thing to have in your toolbox, especially if you're doing drawing stuff like this. It's a little bit outside this course, but it's effectively a list where you store the states of things. So maybe we'll just call that matrices. Or I guess it's a stack in this case. Stack is basically like a list, except you have functions called push and pop, which basically just push means you're putting something on the stack. Pop means you're taking the thing off of the top of the stack. So it's a list that is designed to only take and add to the top of the list, or top of the stack rather. So then you usually have functions like push matrix. So then we're going to do matrices dot push, and then like gizmos dot matrix, and then pop matrix. Then set what did I call it? Set gizmo matrix. Then we do matrices dot pop. And so this is going to set the matrix to the last one we had on the stack, and this is going to add a matrix to the stack. Okay, so instead of like drawing or like doing all of this that we did here, we can simply do push matrix. So this saves the current matrix to the stack. And then we modify the matrix. Then we draw our gizmo. And then here, modifying the matrix happens here. And then at the end, we want to restore the previous matrix. So then we do pop matrix. So this basically makes it so that we have a temporary matrix inside of the scope. What does matrix 4x4.trs mean? So TRS creates a matrix given a translation, in other words, a position, and a rotation and a scale. So using those, it will give you a matrix. Where's Photoshop? There it is. So basically, you specify the origin, you specify the orientation, and the scale of the object, right? And then TRS gives you a matrix that contains those things. So instead of having to like write these numbers in manually, TRS kind of helps you do that, which makes it easier. So TRS is just a very helpful helper function to construct matrices from a position, rotation, and a scale. Okay. So this type of push-pop scheme, very useful. I use this a lot in my own drawing code. And if you're doing a lot of procedural like animations and whatnot, if you're using something like P5JS, then you've probably used this concept before. But yeah, very useful. This should still work unless I messed something up. Okay. All right, we have 2 more things to do. We need to draw the circles. All right. Okay. And the circles is a very good trig problem. So for drawing these circles, we need to know 2 things, right? We need to know how far away it should be, and we need to know the radius of the circle. So we want to draw a circle connecting the outer tips here, right? Okay. And so something that's pretty beautiful about this is that it's quite literally a triangle solve. Shouldn't we center it to the pipe of the gun first? Well, it shouldn't be, well, yeah, we could do that. I guess it depends on what type of trigger we want. But we could do that. There we go. It just can't be relative to the pipe itself, because when the turret rotates, we don't want this one to rotate. All right, so drawing these circles, let's see if we can go ortho again. Let's take a screenshot. Actually, we don't need a screenshot. I can just draw this. Okay, so we have the turret here, right? So let's say this is the turret position. Actually, let's move this a little bit first. Scoot. Oh no, there are other things on that layer. Or on a separate layer, rather. You. Move. Okay. So we have the center of the turret. We have our directions here for the outer edges. Then we have the outer radius. And then we have the inner radius. So now we're looking from above. And then we want to draw a circle. And the circle, I guess this should be straight, so maybe I should clean this up a little bit. There we go. Okay, so this is the circle we want to draw, right? This is looking edge on the circle. So if we go here, we want to draw a circle like connecting these corners. So if we look from above, it's just going to look like a straight line from above. But there are 2 things we need to know here. So one, how far away should this be? So that's going to be this one, right? We need to know how far away it's going to be. Let's call that x. And then we also need to know the radius of this one. And the radius is going to be this part right here, right? Let's call that y. And so now you might be able to see why trigonometry is going to turn out to be useful in so many different cases. Because of course, this makes a right angle triangle. And this edge right here, we actually know how long this is. this is the outer radius, right? So it's the radius outer. Just going to call it r subscript O. And so we know the length of this one. And we know it's a right angle triangle. And we know this angle. This is our field of view divided by 2, right? So we're going to call that f. So f divided by 2. This is half of our field of view. Because our full field of view is this entire angle right here. But in this right angle triangle, we just want half of that, right? Okay, so now we actually have a classic trigonometry problem. We know the hypotenuse, we know the angle, and now we need to figure out the how long these two are. And you can sort of figure this out without even like going to your like trigonometry tables, because the I messed something up. How do you make it so the default was the object's transform position? Not 0. That is setting the matrix. So in undraw gizmo, I set the gizmo matrix to transform.local to world matrix here. Like that. I believe that's it. Unless you missed something else. I'm not sure. Okay. Why is that arrow still there? Kind of don't really want this arrow there. Okay, actually, let's rename these, because the y thing here is specifically the radius of the circle, right? And x is the distance away from the center here. Okay, so we have the angle, and that is f divided by 2. Let's rename it. Maybe we want to call this something else. Let's call it alpha, just to simplify our equations. And let's also give it a color, because that makes it prettier. Alpha. Now, if you remember your trigonometry, then if you have an angle on the unit circle, then the cosine will give you the length of this side right here. So given an angle, and if we assume this is a unit vector, we'll get the length of this side right here using the cosine. But in our case, the hypotenuse is longer than that. It's scaled by some value, right? But that scaling is directly proportional. And so in order for us to then calculate this distance, we can simply scale it by the radius. So we then actually just straight up have our formula. So we can now figure out d. Hold on, my desk is not super great. So d equals r0, or not 0, sorry, ro, that's our outer radius, multiplied by the cosine, because let's add a multiply symbol, by the cosine of our angle, and that's it. That gives us the distance. And then we need to do the same thing for the radius of this one. We can just copy that and then update what functions we're using. And it's the same thing. The sine gives you the y-axis, the cosine gives you the x-axis. So our gizmo radius is going to be, I don't know how to draw r anymore. And that's the same thing, except this time we use the sine function instead of the cosine. And that should be it. That should be all we need to do to get all the properties we need for these circles. All right. in theory. I don't know, maybe I got this wrong, but I think this is correct. So let's do that. We're gonna go on break as soon as I've implemented this. Sorry, I'm a bit late with the break. Because I didn't want to interrupt. Okay, so we're gonna need this in our cone gizmo. So these are the arcs. Then we're gonna need the rings. Can make a local function for that too. Draw a ring, and then we maybe want to specify the for which radius we want to draw it, right? Let's call it R0 because that's kind of what it looks like. Or maybe let's RO. That's fine. Because we're going to need to draw two rings, right? We're going to draw one here, and we're going to draw one here. So it's good to just make a function out of that. So we can just pass in the different like radii we want to use there, right? So I don't know what to call this. Turret radius. I don't know what's a good name for that. Okay, so float distance is going to be our d value. So that is simply turret radius multiplied by the cosine of the angle. And the angle alpha is going to be half of our field of view, right? So field of view in radians divided by 2. So that's our angle. And then we have the radius, and that's going to be the same thing, except it's the cosine, or the sine. All right, and then we draw it. So where's the, I guess it's handles dot draw wire disk. And then we need a center, and a normal and a radius. All right, so the center is going to be just in the forward direction by dist, right? That's going to be 0, 0, dist. Let's make a variable out of that, just to make it a little bit more readable. That's going to be our center. And the normal is just going to be the forward direction. So just vector3 dot forward. And then finally, the radius is going to be the one we just calculated. So we pass that in. I believe this should work. And then we want to call this one twice. We want to do that once for the outer radius. The outer radius and for the inner radius. And I believe this should work. And if it's not working, I'm going to panic. Recompile. Come on, rings. Hell yeah. We did it. Look at these rings. We just did a math. Isn't that cute? Alright. Any questions about that before we go on break? Because we need to go on break. Actually, we should try to tweak this one to make sure that it's responding properly to our things. That seems to work. Beautiful. Isn't math neat? You just solve a thing and then you trust the math and then it works. Imagine that. Okay. People are typing. Have a problem where it didn't detect properly when field of view is greater than 180 degrees, but that's maybe the point. I guess we haven't done the detection itself. Yeah, I'm not sure what could be wrong then. I guess it depends on how you write that code. Yeah, I would have to look at the code in that case, because I'm not sure. Okay, should we do the detection and then go for break, or do we do break first? And yes, the assignments will be available afterwards. They're going to be linked in the YouTube video. 1 vote for detection, 0 votes for break. Okay. 2 votes for detection. Let's do that then. Let's bring back our target. Neat. And then we need to bring back the... Actually, we still have the detection. I just return true all the time. Okay. Let's collapse everything. Cone contains. Here we go. You know what we could do here? We could be a little fancy. If we want to check if the cone contains something, we can actually just hijack the sphere contains function, and just use that inside of our cone contains function, because we need to check the distance as well, right? Like the cone contains one is a subset of the sphere contains. It's a sphere contain check that also has an angular restriction, right? So the first thing we can do is just to check if the sphere contains it, and if not even the sphere contains it, then the cone doesn't contain it either. So we can use that function. So if the sphere doesn't contain it, we can just return false immediately. Okay. Then we need to do an angular check. Because if this returns true, or if the sphere does contain it, it means that it could be inside of the cone. We just need to check the angle, right? I think if we swap between the two, between cone and spherical, you can see that they follow the same like spherical shape. It's just that the spherical is like our cone, except we just cover the entire field of view, right? Is there a better way to hide variables depending on parameters? Usually you would do that with a custom editor. I've sometimes written like attributes to do that, but I forget which project I put them in. But it is possible to do that, yeah. But yeah, the proper way to do it is using editor scripts to make custom inspectors. Okay. So now we need to just check the angle. So we need to check the dot product between the turret forward direction, or the trigger forward direction, and our target, right? That's how we do our angular checks, right? We did this before for the wedge, and so we're gonna do that again. So we're gonna do, we need the vector to the target, or the direction to the target. So that is transformed opposition, no, sorry. Position minus transformed opposition. And then we normalize that. And then we do the dot products. Between transform.forward and the direction to target. So now we're doing this in world space because we don't have to transform it. It would be the same regardless if it's world space or local space here. And then I believe the way that we defined, yeah, we have the angular threshold here. Because we changed it to use degrees here. Right, okay. Yeah, so that's our angular threshold. So I think we can just check that. So for projected angle, it has to be greater than the threshold, I believe, for it to be inside. And I think that's it. We could also check angles directly. That would make this code a little bit more readable, but a little bit slower, but that's maybe okay. So we can do, so vector3 dot angle, and then you can measure the angle between two vectors. So that would be transform.forward and direction to target. So we can use that too. This one returns in degrees. So we could just check that, check if this is less than the field of view in degrees divided by 2. So we could do that too. Yeah, so there are many ways of doing this. Or we could do the angle manually, like we did before. We can do, can calculate the angle using the dot product. So we can do vector3 dot dot between direction to target and transform.forward. And then we can do the arc cosine. And that gives us the angle in radians. Yeah, and then we do the same thing there. Return angle in radians is less than field of view in radians divided by 2. Many different ways of doing this. This one you might have to clamp between 0 to 1 or -1 to 1. Sometimes you get floating point precision issues. So I believe vector3.angle basically does this same code. Except vector3.angle probably normalizes it for you. So it might be a little bit slower. Yeah. And so you can do, so for this one you probably want to do, just clamp this one. Between -1 and 1. And so probably this is something you should make a function out of. Vector3a, vector3b. So angle between a and b. And then there we go. And this is specifically the angle between two normalized vectors. Because it doesn't normalize A and B. It presumes they're already normalized. So then we can just call that one transform.forward and direction to target. So I think this one would be slightly faster than Unity's function because Unity probably normalizes these, but we already know that these are normalized. And so we can take a little bit of a shortcut. Yeah, so again, many different ways of solving the same problem. But this should work. Maybe it doesn't work. Maybe I've just been talking about these things and it doesn't work at all. But hopefully this works. All right. I guess let's test it out. Doop, 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 doop. It's outside. That seems correct. And it's inside. That seems correct. Outside. Outside. Inside. Outside. Yeah, I think we did it. So someone had an issue with a field of view greater than 180 degrees. So let's open this up a little bit. Let's go to 340. Or heck it, let's just go 360. Do the whole thing. Let's see if this works for that. I think it should. So let's increase our field of view. And now we have a Now we have a very almost bubble in front of us. And so that does seem to work. No, this one counts as inside. So that doesn't work actually. Let's hold on. So let's see where this goes wrong. This actually counts as inside already over here. So we've done something wrong. There's probably some symmetry somewhere. I'm guessing it's doing the same thing on both sides, maybe? What is it doing? Let's see. Direction to target. I feel like it should work. Anyway, we should go for a break because we've been going for 1.5 hours, which is longer than we usually do. And I can investigate this during the break. Probably something with a clamp, maybe. Value, min, max. That should be correct. I'm not sure what could be wrong. I'm not sure. But yeah, let's go for a break. Let's resume at 10:40. 10-minute break. There we go. Oh yeah, the clamp is in the wrong. The clamp should be in the dot products, not in the angle. There we go. That's the thing. Have you committed to Git? Not yet. Right. So the problem was that the arc cosine only accepts values from -1 to 1, and so we want to clamp the result of the dot product. Mathematically, this clamp should never be necessary. So the actual math function looks like this. But because floating point representation works the way it does, you might have some inaccuracies. And so you want to clamp this to ensure that it never goes to like 1 point tiny number, right? Have you committed to Git? Not yet. I don't want to commit broken code, but I think this should make it work. Okay, that seems to work, I believe. Okay, now let's do our wedge trigger, increase field of view. I believe that works. Yeah, so we had the math right, I just did a typo. I put the clamp in the wrong place. But otherwise it's working. All right. What a funky trigger. I like the shape of this trigger. It looks really neat. All right, now I should commit. Go full 360. Okay, just a moment. Okay. What do? We added the cone trigger. Okay. I feel like I'm hunched over. I'm completely unaware of my posts. Uh, mm, mm. All right. Where are the kittens? We have a toast in the window. I don't know where Thor and Salad are at. Oh, Thor's in the bedroom. But where's Salad? I'm gonna go find Salad. Wait, what? The students pay her? My students don't pay me, personally. These are lectures for a school called FutureGames, and it's people who are enrolled at FutureGames that are getting this lecture. And so I'm reading their private chat for this, and then I'm also streaming it just in case some other people will find this useful, and because I requested to do that. So you know, technically paid for a Twitch sub yesterday. Okay, well you might be paying me then. Solve my issue. There was an and or thing wrong in my method thingy. Oh, gotcha. Logic error. Okay, I should make more tea. I just need more tea. Took your lunch money? Oh no. Are you presenting at Unite? Yes. Okay, shit. I'm late. Our break is a little longer than usual. I'm sorry. I need to make my tea. It's important. Any questions so far? Otherwise, tea is like so essential to my like sustained being. What's that table-like device next to you? What? Device? I'm not sure which one you're talking about. I have a table behind me, and then I have DDR pads. There are cat trees. There's more cat trees, and there's Ashley's desk, who's not at home right now because she's at work. Then there's the couch. And then there's me. Those are the only table-like devices I can think of. DDR is my workout. I haven't played DDR for so long though. I should really get started again. Are you a table-like device? Yes. We're kitties. Well, I think Toast is the only one that might be visible. There we go. Look at that boy. He's just a little nugget. Although it's focusing on the wrong thing. Hey, focus on the cat. There we go. No, no. It's. Come on, camera. There we go. Hell yeah. Look at that cat butt. Oh yeah, you were asking what breed they are. They are ragdolls. So they're not the Berman, which a lot of people think they are. I think Toast looks very much like a Berman, but they are, both Toast and Salad are ragdolls. Okay, gonna get my tea. Enjoy Toast in the meantime. Okay. Yeah, I should probably put some cat beds in the windowsill. We used to have a cat tree in the window, but the cat tree broke. I'm not sure what happened, but I think they tipped the cat tree at one point and it fell into the kitchen and shattered a plate and a glass, and the cat tree itself also broke. They had zoomies and they were flying around both like laterally and vertically. It was a lot. Okay, all right. let's resume. I have my tea. I'm now ready. Freya stealing our lunch money? Bad. To buy more cat beds for salad? Good. True. It all cancels out in the end, doesn't it? Okay. All right. Let's resume. There we go. Please react to the message if you're present. Blip, 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 blip. Okay, cool. All right. Okay. So I believe the only thing we have... I don't think we have anything left on the triggers themselves, right? We've implemented both of them. So I think we should just reset it to something reasonable. Like so. All right. What is the next assignment? We had the trigger modes, and I believe we did... Yeah, we did everything. Did all the trigger stuff. Now we got the clock. All right. Some of you did the clock. Or did all of you do the clock? I forget. You did. Okay. I think I saw 3 different clocks. How was the clock assignment? Did it work out? It's mostly an exercise in range remapping and for loops and off by 1 errors. That kind of stuff. 24 hours was cursed. Look, 24-hour clocks are super cool. I love them. They're really neat. You haven't had time for assignments, you're catching up? Gotcha. Okay. Let's make a clock. Let's just make a new script. Call it clock. Let's put it somewhere. Maybe here is fine. Although I probably want it to be snapped somewhere. All right. Writer, please react accordingly. There we go. Gonna draw on our gizmos as usual. What's weird with the clocks was that I needed to offset the angles for the hours by 3 and the seconds by 15. Yeah, that is because if we go back to our trig circle here, an angle of 0 points directly to the right. But clocks generally start at the top. But in mathematics, angles always start to the right. So 0 is to the right, and then you increase as you turn it to the left, right? And so there's gonna have to be some sort of conversion here, right? Okay. Took me a while to figure out why my clock was 3 hours ahead when it was 12. Gotcha. Okay. So what is... How do we start this? I guess we should start by drawing a circle. Handles dot wire disk. Let's just set the gizmo here as well, or the matrix. Handles dot matrix equals gizmos dot matrix equals transform dot local to world matrix, just so we can move the clock around. Then we should draw the disk, and where do we draw it? Just default with a radius of 1. And the normal should be vector 3 dot forward. Okay. I believe that's it to draw that disk. Neat. All right. So now this is kind of an exercise in like remapping ranges and figuring out, like, you have some value in some range. We have a range of 0 to 60 seconds, but then we need to map that to something else, right? We need to map that to an angle. And so it's going to be a lot of remapping now. We're going to talk more about remapping today in general. And so this is kind of a way to do both trigonometry and sort of an intro to that. Okay, so we want to draw some clock hands here, right? And we want to draw, let's see, how many? We want to do 3 different ones. One for the seconds, one for the current minute, and one for the current hour. But what the type of function we basically need here is that we need a way to convert from a minute to an angle, from a second to an angle, and from an hour to an angle, right? And so it might be helpful to write those functions first and then kind of test them out to see if they work, to make sure that we got everything right. So let's make a public property just so we can test it. Let's see, we're going to make a range from 0 to, let's do minutes first. Or seconds. They both go to 60, I guess. All right. And then we want to draw a thing so we can like debug our direction to make sure that we got this working. So we're going to do handles dot draw. I guess we're going to do draw ray in this case. Or I guess a gizmos. Oops. From 0 to some direction, right? So we're going to want a function that is going to convert from seconds to direction. All right. Okay. Seconds to direction, pass in our seconds in there. This is our test value, I guess. Let's just clarify that. Okay. So there are kind of 2 steps involved here. So 1, find the angle. And 2, convert to direction. So converting to direction, this is something we've done before. This is the the basic trigonometry of, if you do the cosine, you get the x-coordinate of the vector. If you do the sine, you get the y-coordinate. And so all you need is the cosine of the angle and the sine of the angle, and then we get a vector out of that. It's a very useful function to have in your toolbox. So that's why I always have it in my math library and in all of my projects. So it's always useful to have that function. I guess we should use vector 2's. So we basically want an angle to direction function. So angle, should clarify that it's in radians maybe. New vector 2, and then the cosine of the angle, and the screaming cat in the background for the y coordinate. So angle radians. There we go. So this is just to convert an angle from a direction. And again, we have the cosine for the x-axis, sine for the y-axis. Door! Mistro! Mistro Bistro! Wow. Okay. So now we need to find the angle. We have the conversion to direction down, so we just need to return angle to direction, angle in radians. But then we need to find that angle. So what is that angle? Okay. There are a few ways you can do this, a few approaches. One approach that I like to do is to first convert the seconds into a normalized range. And by normalized range, I mean converting it from a range of 0 to 60 to a range to 0 to 1. And so if you take the seconds here and then divide it by 60, as in the maximum of that range, we get a percentage. So seconds divided by 60. This will give us a how far we are to repeat the whole pattern from 0 to 1. So this is kind of our angle in turns, but it's also kind of a percentage for how far we are from 0 to 60, right? But expressed as a percentage. And a reason not to use modulus? So far, we're not doing anything related to modulus. This is just directly converting from seconds to a direction. We're assuming it's always going to be from 0 to 60 now. Okay. So now that we have a normalized range, it's actually very easy for us to convert that to some other range. So if we want to convert a value from 0 to 1 to an angle, then if we go back to our angles, which exist somewhere, I hope. Where are my angles? Oh, here we go. Remember how we had this unit called turns? That's effectively what we have right now. We have a unit that goes from 0 and then all the way around to 1. Because we took our range of 0 to 60 and then we just converted it to 0 to 1. So we basically have our angle in turns. And if we want to convert turns to radians, all we need to do is multiply by a full turn in radians, which happens to be tau. If we want this in degrees, we can do the same thing. We can multiply our angle in turns by 360, and then we get the angle in degrees. Okay. And so we can just multiply our t value by tau, which is, I guess, pi times 2. You know, let's go to Google. Tau times 1. Thanks. Okay, tau. There we go. We got it. All right. Okay, let's see if this works. Where's Unity? There we go. should just have a slider now where we can just input a value. All right, so I have 0, and then we can set it to 15 seconds, 30 seconds, and 45 seconds. And we can say that it goes all the way from 0 to 60. But we still have the problem of the orientation, right? So there are two problems, basically. One, 0 should be at the top, and it's also going in the wrong direction, right? And so that's not super cool, right? Okay, so there are a few ways we can do this. We can either offset the angles in all of these. We offset the angles or mirror the angles and so forth. Or we can be a little bit cheeky and we can modify the matrix. We can kind of just like rotate the whole thing and mirror it using a matrix, which is a little bit cursed, but either of these would work. I think it's better to modify the angles in this case. Otherwise, we're gonna have a bit of a disconnect between the matrix and the way we draw the angles, and that's gonna be a little bit confusing. So I think it's best to modify the angles here. Yeah. So we're gonna wanna adjust that, right? Okay. So let's see, where do we want to do this? We could maybe do that as a function where we pass in the normalized value. What if we just flip cosine and sine? We can do that, but then this function is going to be incorrectly named because we have a special case, right? And so I want this to be pure, like a pure function that does what it's supposed to do and not anything like clock specific, right? So we probably want the angle itself to be corrected. So maybe we make a function called so a fraction to clock angle, maybe something like that. So then we pass the t value in here. I guess we can do the direction directly if we don't want to deal with yeah, let's do the direction immediately. Just move this in here, because we're going to reuse this for everything else. So we want to, it's nice to keep things modular, right? So we're just going to pass t in there. Okay, so far I think this should just be the same code. I don't think we've made any changes. We've just like refactored it, just to make sure. Okay, so 0 is there, and then it goes all the way up there. So that is still wrong, and that's good. So we want to fix that. So there are two things that are wrong. We're going in the wrong direction. So that's the first thing we need to fix. That's an easy one. We can just negate it. We just negate the angle. I guess we could do that here. Let's recompile. And now it's going in the other direction. The next thing we want to do is we want to offset by half a turn. And half a turn is tau over 4. Or sorry, a quarter turn, not half a turn. And so a positive rotation is going in this direction, right? So we want to add tau over 4. So we could either do plus tau over 4, or we can add 0.25 to this. This one is a little bit more descriptive, but it's slightly more performant to do this, because now this is in turns, right? So either of these would work. And then let's go back, recompile. And there we go. So now we go from 0 to 60. And we have our angles correct. Okay, any questions about that so far? A little bit of math. Guessing no questions. Maybe? Or maybe some questions? I'm gonna have some tea and ponder. Still going counterclockwise for me. This sign, this minus, is the thing that changes the direction. Also, make sure you're viewing it from the correct direction. So that you have x, the x-axis to the right, and the y-axis up. Yeah, you want to look at the direction where x is pointing to the right. You can look at the top right of your viewport, and y is pointing upwards. So if you click here to isometric view, and then click here and get the back view, and then you should be good. You got it. Okay, cool. All right. So far so good then. So this can be used for both seconds and minutes because they're both 60 seconds, 60 seconds in a minute, but there's also 60 minutes in an hour, right? So those kind of seconds or minutes. Okay. What was the purpose of 0.25 minus t times tau? So this was to, 1, make it go in the opposite direction. That's the negative sign. And 2, we wanted to make it start from the top. So we offset the angle by a quarter turn. 0.25 is a 1/4 in turns, right? Yeah, so the negative sign is just to make it go the other direction, and 0.25 is to offset it so that it starts from the top. I really need to go to the bathroom. I'm sorry, but feel free to ask questions while I go to the bathroom. Oh, sorry, I was muted. Okay, so all of this makes sense. That's good. All right. So let's just organize this a little bit. So these are basically our math utilities. Okay, everything else is clock specific. Okay. So now that we have a way to convert from seconds or minutes to an angle, we can start drawing little marks, right? Or draw the current amount of seconds. So I guess, let's see, do we start with the tick marks or do we start with, I think tick marks is useful. So let's do tick marks. Okay, so let's make a function for drawing a little tick mark. And we give it an angle. And then we want a length for how long it is. Maybe thickness. I forget if Gizmo's draw line has a thickness parameter or if we need to use handles. Okay, maybe we have to use handles. Handles draw line, that one has a thickness, right? Okay. Okay. So, we're gonna have to draw a few of these. So first we want to draw the tick marks for minutes or seconds. There's 60 for both of them, so. Okay, so we want to draw 60 of them. And then we effectively call our drawTick function. And then we want the angle is something we get from, or I guess angle is harder to use here. Let's just use direction because I have a function for that. drawTick in a specific direction. That's going to be seconds or minutes to direction. We just pass I into it immediately. Just straight up, because this is iterating seconds. And then we're going to draw a tick in the direction of some length, 0.05 or something, and thickness 1. Then we need to do our drawTick function. All right, so we are going to do draw handles. I'm used to my own vector library. I'm not used to drawing handles. Draw line from direction to, and then we want to scale it down. And so you might want to do, there are many different ways of doing this. You can either do vector math or you can just multiply by scalar. So in my case, I want to do 1 minus length. I think that's the most optimized way to do this. So we want to shorten the direction vector. Again, the direction goes out to the edge of the clock. And then we want to like offset it inwards a little bit. So we just want to shorten it by multiplying it by some value less than 1. So we just subtract length from 1, and then it's going to be less than 1. So the bigger length is, the smaller this value is going to be. Okay. Could actually expose that as a parameter. So we're going to want to go from 0 to not more than 0.5. That's a lot, actually. 0.2. Okay. I believe that's it. Oh yeah, I want to pass thickness into it. Draw thick tick. Let's see if this works. Brrr. Got it. And then we can change the size if we want to. So 0 is invisible, and then 1 is very large. So there we go. Little tick marks. Okay. Neat. Oh, it's Salad. Salad is here. Salad. Hey. That's not a scratching post. There's a salad. Salad. What? Oh, he's off. Hey, Salad. Hey, buddy. Hey, come on, Salad. It's a spring. It's a spring. Oh. Slap. Okay. What a good salad. We all appreciate salad. Sorry, we have to have cat intermission sometimes. Okay, neat. And then we want to do larger ones. So we want to do the ticks for the hours, right? So we did minutes and seconds. And now we want to do hours. All right, how many hours? We're doing 12 hours for now. So there are 12 of them, and then we want to do hours to direction, right? So then we basically need to make a similar function, except we use hours instead. So we could make a helper function for this, just wrap it in another thing. So let's see, this would be, what would we even call this one? To angle or something. Time to angle. Value to angle. Okay, there we go. So we want float for the value, and then we want another float for the value max. And then or value to direction. So then we can do the same thing here, where we divide the value by value max. And then we can just call that function here and do seconds or minutes and then pass in 60, because that's our maximum value, right? Because we're going to do the same code for all of these. Except the only difference is the maximum value and the name of the input variable, I suppose. I should probably do that. Shorter names are good sometimes to make it a little bit more readable. All right. And so we need to do the same thing for hours. So we do hours to direction. Let's shorten direction to dir. It's good enough. So in this case, we're remapping the hours to with a maximum value of 12. Okay. And then we can do the same thing here as we did in minutes and seconds. We just called a different function. We call hours to direction. And then we want this to be thicker, so let's do 3. Then maybe we want a different size for this one. So we're passing in tick size hours. And I believe that should be it. Okay. There we go. We have some large ticks now. We did it. We drew the things. I think this is correct. Yes, 5 of them per thing. Cool. Okay. Did all of that make sense so far? It's a little bit of a remapping and nested functions situation here, but hopefully it's understandable. It's a bit fast, but I think I understood the gist. Right. Okay. If I'm going too fast, let me know and I can slow down. I know that I have a tendency to just kind of go a little bit too quickly sometimes. Okay, I'm gonna drink some tea to see if I can slow down a little bit. Okay. People are typing. I'm gonna heat up my hands using a cup of tea. I think a little fast is okay since we can always watch the stream back to get it again. Yeah, I feel like I just want to make sure you can understand it in the moment as well. Yeah, because I don't want this time to be completely useless. I don't want it just for the purpose of the recording, right? It might be hard if you're trying to like follow along in real time, but I'm not expecting you to do that. Okay, all right. Although we're gonna have to speed along because we're approaching lunchtime, so we're gonna speed this up, because we need to do assignments before lunch because we have stuff to talk about after lunch. Okay, everything is cool so far, right? And so now the only thing left to do is to actually show the current time. We're not doing that at all. So might want a similar function for drawing a clock hand, right? So draw a hand. We're gonna do direction and length and thickness. The only difference is that we're gonna do the length from the center now instead of length from the outer side, right? And we're gonna draw it from the center. Okay, maybe we will throw in a color here as well. Why not? What? Or I guess it's handles. So this is a handy little thing you might want to use. There's a thing called a color scope or drawing scope. Remember how we set a temporary matrix before using push and pop? A drawing scope basically does the same thing. When you leave this scope, it resets the original state. So you can pass in a custom color in here without the colors affecting everything outside of the scope here. So it's a useful little function. All right, so we're gonna draw our clock hand. Draw a clock hand. And we have our seconds or minutes to direction. The length of this one is going to be pretty long. And then the thickness is going to be thin. And we want the color to be red. Because this is the one showing seconds. Okay, there we go. Faint little red line. I made the hours red. I think traditionally, or at least the way that I'm used to it, the seconds one is usually red and thin. All right, cool, we did it. But then we might want to use the actual current time. So we have datetime dot now gives you the current time. And I believe this gives you a datetime type. So instead of using our test variable, maybe we should use the actual seconds. So I think we can just use time.second directly, and I believe that will make this work. So let's recompile, and let's turn on live scene view, and it seems to work. Let's see, is that correct? 27, 28, 29, 30. It works. This is correct. It's the same as my Windows clock. So we made some progress. We did it. And then we basically do the same thing for the other ones. So we duplicate this, draw clock hand, and we want to do the minutes one in this case. So minute, and then maybe this one we just default to white. This one is going to be a little bit shorter and thicker. And then we do the same thing for the hour. And then we change the function because now we have to use the hours to direction. And we'll make this one even thicker and even shorter. And I think that should do it. Let's recompile. Yeah, that seems to do it. We can tell that we're approaching lunch. We actually have an indicator for how much time we have left to do the assignments now in Unity. Isn't that cool? We can just tell immediately. All right. Yeah. That's, I believe, many of the assignments. Okay, so that was 9A and 9B. Right, 9C is if we want to animate it smoothly. Okay. Is there an easy way to display numbers? Unfortunately, OnDraw Gizmos has this weird offset when you draw numbers. There is a thing called handles.label, but the problem with handles.label is that it has this y-axis offset in screen space that looks really ugly. But you can use handles.label, it's just going to be positioned weirdly. And so it's a little bit cursed, but it can work. So yes, there is a way to do it, but it's going to be annoying to get it right. Okay, the last thing is that, or for 9C, we want to have a toggle if we want the red to be smooth or not. So we're going to add a parameter. Used handles.label. So did you also get the y-axis offset? Like it's slightly offset on the y-axis, or did it not happen for you? Let's see if it happens for me. Yeah, so it says 12 here, right? But for some reason it's not drawing up here. And the reason it's not drawing up here is because of the toolbar. The size of the toolbar will offset all of your labels, which is really gross. And so if I do another one, what? No, down. Then now this one is going to be under. And so this is kind of a really annoying thing about the labels, that they're offset vertically. And so they're a little bit fidgety, and that makes me sad. But yes, it's possible. Okay, so we want to make this one smooth. So I believe we have time dot millisecond. So that is an integer, and milliseconds is going to be 1,000th of a second, I believe. And so we want to modify this one if we want it to be smooth based on the millisecond value, right? And so let's add a Boolean value. So this is going to be a smooth seconds. Yep, and then we just toggle that. So float seconds equals what? Time dot second. And then if we have smooth seconds enabled, we're going to do seconds plus time dot millisecond divided by 1,000. So now we're adding the fraction. We're converting the milliseconds to seconds by dividing it by 1,000. And then we're adding that to the seconds, and then we're going to draw the seconds here. I believe that should be it. Let's recompile. And then smooth seconds. And then there we go. We turn it off. It snaps back, which is correct. Turn it on, then it moves forward. Yeah. So there you go. Smooth seconds. And then we had another option. Another option we wanted to add was to configure whether or not we want a 12-hour clock or a 24-hour clock. My seconds only updated when I click the viewport. You can enable real-time viewport updating here. At the top, there's a little drop-down, and if you select always refresh, it will update the scene view every frame. Yeah. Although that's going to make your computer process a lot more because it has to update the scene view all the time. So it's going to re-render everything. Just a heads up in case you're on a laptop with limited battery. Then be careful with that setting. Alright, the other thing, ooh, that's handy. Was that a pun? Because we're doing clock hands. It doesn't update every frame anyway. For some reason, it only does if I hold down the middle mouse button to drag the scene. I think if you enable always refresh, it's going to refresh at 60 FPS, I think. But if you hold down and move, it's going to refresh at whatever is required based on your mouse movement. So then it's going to be higher frame rate. I don't know why it's limited to 60. It's kind of annoying, but... Okay. Use 24-hour clock. All right. Not refreshing every frame? Really? Are you sure you ticked the always refresh thing? Because if that's not working, then I'm not sure what's wrong. Okay, so if we use the 24-hour clock, it might be useful to just have a property then for how many hours we have visible, right? Like on the whole thing. So we might want to have an integer to get that number. So hours visible is going to be use 24-hour clock, 24. Otherwise, it's going to be 12. Or we could just call it hours on clock. But that's probably a better name. So hours on clock. We're going to pass that in for the ticks because we're going to need to draw 24 ticks if we enable that option. And in our hours to direction function, we also have to pass in this value. Because now it depends on that variable, the number of hours on the clock, right? And I believe that's it. I think those are the only two changes we have to do to add 24-hour clock. And recompile. Here we go. And use 24-hour clock. And that seems to work, I believe. So that's 11 down here, and then 12. And then here's, this hour is the lunch hour. And so I believe that works. You can toggle between the two different clocks. Is clock ridiculous? The thing I really like about 24-hour clocks is that you can mark things. You can actually mark, like, when is sunset? When is, like, sunrise? When is your working hours? When is lunchtime? Like, all of that can be, like, you can just visualize that on the clock, which I think is super cool. But you can't do that with a 12-hour clock because you have this, like, overlap, and that sucks. I like 24-hour clocks. That's why I think they're neat. Because then you actually have a dedicated side of the clock that's like nighttime, right? All right. I made a clock that was based only on seconds. Yes, if you can do that too. Then you're gonna have to use a lot of like modulo stuff. If you use time.minute and time.hour, it's gonna basically do that for you. And so it kind of depends on which approach you want to take. Okay, I think that's it for this assignment. Any questions about this? Otherwise, I'm just going to commit and then move on to the next. The clock literally only had one hand, and I did 360 divided by... Oh, right. Right, okay. Oh, that's weird that it's not refreshing. I don't know. I would restart Unity. That seems deeply cursed. I'm not sure what's going on. All right, I'm gonna commit this to the repository. That is now pushed. Okay, we did it. 24-hour clock. All right, we have 2 more things before lunch. I think we have enough time. I think we can do this. Whew, okay. Mouse look. This is a classic thing you're gonna probably do many times in game development. So in this case, we wanted to move the turret code into update so that it's interactive in the game view. So we're just gonna leave the clock there. We can just let it hang around. You know what? What if I put it in as a child object of the gun? Isn't that cool? Look at this turret keeps track of time. That's a neat turret. Or maybe not. It was a cool idea. I like the idea. Okay. So now we need to make it so that when we turn the camera, that's when we should place the turret. Okay. So it's currently in on draw gizmos, so we're gonna move that. We're gonna move that into an update function. Just gonna move that. I didn't put a limit on turret field of view. Oh god, is that like beyond 360? Nice. Oh shit, I can't play music. I'm gonna get banned on YouTube. It's a nice music visualizer. Alright. No longer using on-draw gizmos. We're doing this in update. So we might want to make a separate function for that. Place turret. There we go. I'm gonna need to null check this. It's always gonna be assigned. Okay. So let's see. Our turret placer is living on the camera. And so we're gonna have to add some more code now to turn the camera using the mouse. Okay. There are, again, many different ways of solving this. But we're gonna add a function called update mouse look. And I believe the mouse look is input.getAxis mouse x, at least using the legacy input system. And so this is the x delta, I believe. As in it's not the current position of the mouse, it's the velocity of the mouse. Then y delta is mouse y. I guess we can just debug.log these things just to make sure. Okay. And we want to update the mouse look there, just to make sure we get the values we're expecting. It's always good to do that. Sometimes if you're writing a lot of code, you have these like lots of different moving parts, and then something doesn't work in the end, and then you're like, I have no idea what's wrong in this whole thing. So sometimes it's good to just do these little test functions just to like sanity check your input. So for instance, I have an argument exception because I'm trying to draw gizmos in update, which is bad. We don't do that. So we're just gonna delete that. I guess we can do debug.draw line instead. So then we pass the color, then we pass the points, and that should work instead. So debug.drawLine is more for like drawing things in the game view and while the game is running. Okay, we are drawing that line. That's the middle one here. And our console has a bunch of values, and it seems like it's 0 when I'm not moving the mouse, and if I move it slowly to the right, you can see that x has a value here, and y has a value if I do this, negative if I move down. So this is effectively just the movement of the mouse. It's showing the delta, the velocity of the mouse, effectively, on each axis. Okay, and so now we want to set the look angles based on these delta values. And so we're gonna have to drop our pens. Okay. So the situation we have is that we have a camera that is pointing in a forward direction, right? So if you imagine this is the camera right here. Beautiful camera. So this is the camera direction, so that's the forward direction. And then we have the y-axis, so that's going to be here. And then the z-axis is to the right. So that would be that direction right there. So these are the axes that we're dealing with, right? When we do mouse look, there are effectively two things we want to do. When we move the mouse left and right, we want to rotate around this axis, right? Around the y-axis. So this is our left and right axis. And then when we look up and down, we want to rotate around the x-axis. And these usually have special names when it's specifically these two rotations. So this one is usually called pitch. And this rotation is usually called yaw. And then, of course, if we rotate around this one, That's usually called a roll. Okay. So now when we want to do mouse look, these are the two axes that we care about. And we can either do this using quaternions, or we can use Euler angles if we want to. This is one of those special cases where Euler angles are actually useful because of the way that they're set up. So otherwise, if we were to do this using quaternions, it would get a little bit more complicated. Where are our Euler angles? Right, here they are. So with our Euler angles, Unity's rotation order happens to be very useful for mouse look. And the reason this is because it has this rotation order. It's because it's doing the y-axis first. And so where's my gizmo? Here it is. Okay. So the thing about the mouse look is that the blue vector is the forward vector, right? With mouse look, you want to do yaw first, and then you want to rotate around the x-axis for up and down look, right? If you did it the other way around, if we're doing the pitch first, and then the yaw, we're actually going to tilt the camera. So if we do pitch first and then yaw, we suddenly have a roll relative to the world's up vector. And so it kind of just so happens to work out in Unity's Euler angles that because it's doing the y-axis first, it just works out. And so I kind of glossed over this a little bit last time, but that's useful. That's probably why they ordered it like that. That would be my guess, yes. And so Euler angles just kind of happen to work out. I kind of glossed over it last time, but the difference between intrinsic and extrinsic rotation is that extrinsic is world space and intrinsic is relative to the own axes. And you can sort of interpret Unity's Euler angles in either way because these two are actually equivalent. And so it's kind of, when you think about the orientations, you actually get the same results if you rotate around the world space z and then the world space x and then the world space y, instead of the like relative axes that you get. But it's just useful to remember that this is the order, and that just so happens to be the order that we need for mouse look. Okay. And so this actually turns out to be relatively simple. So first off, we want to save our pitch and our yaw, because we need values for that, right? And when we move the mouse, we want to modify the pitch and modify the yaw, right? And remember, pitch is looking up and down, so that's going to be the vertical mouse movement. So we're going to do pitch plus equals y delta. And then we're going to do the same for yaw, plus equals x delta. So that's the horizontal mouse movement, should rotate around the yaw, the y-axis, right? Salad, what are you doing? Hey, Mr. Salad. Right. We don't need to log this anymore. Then we want to set the rotation of Salad. Boy, you're being a little rascal right now. He just unplugged my monitor. Salad. Illegal activities. No. Yes, we want to set the rotation of Salad. Hey, no. I need to find a toy for salad. Piece of plastic. Here you go. Here you go, salad. ASMR plastic. You want ASMR plastic, don't you? You come get it. Come get it. I want you to stop playing with my cables. Yeah, play with this. Plastic. No, no. Okay. Let's try again. Hope he doesn't unplug my monitor. Alright, so now we need to set the rotation. So we do transform.rotation equals quaternion.euler. And then here we simply pass in our values. So the x-axis is going to be our pitch, right? And then the y-axis is going to be our yaw, and we don't have any roll, so we're just going to pass in 0. Salad, no. Okay, I'm going to have to evict this boy. Hey, hey. Miss the salad. Okay. Hey. All right. And that should be the solution. I don't know what to do with this boy. He's being a little boy. Mm-hmm. Okay. Okay, maybe I can put him in my lap. Ow, 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 ow. No, ow, ow, ow. Okay, you're being a little baby. Here's your plastic. Here's your plastic. Nom, nom, nom. Oh, you like plastic. Okay. So, transform.rotation, we're setting that to the Euler angles. We have our pitch, we have our yaw. And let's see if this works. We're gonna have to tweak this. There are a few things that are not gonna work very well. So let's see if this works. Let's press play. And now we have a very basic mouse look. We can look right, we can look left. See that the turret is actually tracking our target here, so that's good. But the vertical axis is inverted. When I move the mouse down, I'm looking up, and when I move the mouse up, I'm looking down. So we're gonna have to reverse the up-down movement. We're gonna do y delta is gonna be negated. And then we might also want to, we might also want to be able to set the mouse sensitivity. It happens to be pretty good for me right now, actually. But should pitch minus y delta work? Yep, same thing. You dropped it, Salad. You dropped it. Here you go. Here's your plastic. Boop, 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 boop. Nope. Okay. So if you want a mouse sensitivity, that would basically just be a value that we multiply the delta by, right? Salad? Don't tear my headphones down. Hey? Okay. What a boy. So all we need to do is multiply by the mouse sensitivity. And then we also want to clamp it. Because right now we can actually look up until we're upside down. which is usually not super ideal. Generally, you don't want to allow looking upside down in games. So we're gonna have to solve that too. And because we have pitch and yaw as separate variables, we can clamp pitch. We can clamp pitch directly. Yaw we shouldn't limit anywhere. We can just look in any direction. But for pitch, we want to clamp it. So we're gonna do pitch equals math.clamp, where we want to clamp the pitch value from. So in this case, I believe we are using degrees. So we should clarify that. There we go. And so in degrees, let's see. So that is probably going to be from like negative 90 to 90, somewhere there. Depending on what limits we want to use. It's a little bit risky to have it exactly on 90, but should be fine. I believe that's it. There we go. Up and down is in the correct direction now. Change mouse sensitivity to 2. Now it's faster, and so forth. So now we have a basic mouse look. We did it. Okay. Did that make sense? There are a few polish things we might want to do. For example, we don't actually start at this angle right now. So we might want to extract the start angle, because when I press play, it resets to 0, right? And so we might want to just set the yaw and the pitch based on the start rotation. So start Euler angles is transform dot. Actually, I think there might be an Euler angles property. Yeah, I almost never use this. Then we set pitch to start Euler dot x, and then we set the yaw to start Euler dot y. Okay, and then yes, we might want to lock the mask too. So I think it's like cursor dot lock state equals locked, and then we can set visible to false. Usually you also want a way to escape this state. So if input dot get mouse button, or we will do key, get key down, key code dot escape. Then we probably want to get our cursor back. Okay. So I think this should do it. Let's recompile and test. So press play. See if my cursor disappears. And it does. There we go. It's locked. And I can look around, and it's working great. Okay. Then we have one more thing left. Actually, let's first commit this code. Okay, there we go. Added mouse look to turret. Turret placement. There we go. Let's push that. A bit off topic, but do you prefer inline brackets or new line? I'm using my current preferences right now. And so same line is what I prefer. just because I feel like indentation should signify scope. And so having this just feels wasteful. In my ideal language, I feel like it should just look like this. But this is not Python, and so we can't do that. But so we have to have brackets. To me, brackets just feel unnecessary, but we have to have them. Okay. So, where is, well, what are we doing? We're doing, right, we wanted to adjust the, we wanted to add a modifier so you could adjust the yaw of the turret. That's the last thing we want to do, right? So, we're going to add another float for turret yaw offset. And then we want to add another function, update turret yaw input. Okay. Then we want to do input dot mouse scroll delta. And we want to do the vertical scrolling. So float scroll delta equals that. And then we want to do yaw offset plus equals scroll delta. And then we might want a modifier for how quickly we do that. So it's kind of like turret yaw modification sensitivity or something. So turret yaw sensitivity. I think we might want to increase that immediately from the get-go. I'm gonna set it as 6. So this is gonna be in degrees as well. Okay, so we update the turret yaw input. We update the mouse look. And then I guess we should only do this if the cursor is locked. So if it's not locked, we don't do this. Okay. It might actually be easier to test this with a public variable first. So that's what we're gonna do. We're just gonna add a range from -90 to 90. All right, so we have a yaw offset for how we want to place the turrets. So after placing the turret, we want to rotate it around this local y-axis, right? And so what we're gonna have to do is in our placement code, where we place our turrets, is that we set our rotation of the turret here. So this is based off of the surface vectors and all of that kind of stuff. But we want to offset this rotation, right? So we're going to define an offset as a quaternion. Offset rotation. And here we can either use quaternion.angle axis or we can use quaternion.euler, whichever one we want to use. Either of them works. So we want to do a rotation around the y-axis specifically by our yaw offset. So that's our offset rotation here. And then we want to composite these rotations, as in we want to do one rotation first, and then we want to do the other rotation. And that's exactly what you do when you multiply matrices together. So we simply multiply by our offset. So what that means is that it's going to first rotate based off of all of the placement vectors we set up before, and then it's going to rotate around its local y-axis, because that's the orientation we define here. And so the order of rotation if you interpret it using the intrinsic axes, as in the axis after each rotation, then that's the order it's gonna do. It's gonna first do this and then rotate around its local y-axis. If we flip the order and do offset rotation first, it's gonna rotate around the world space y-axis, and then it's gonna do all of this look rotation stuff in its local space. And so that's not gonna work out very well. And so I believe this is all we have to do our offset rotation. So now we're combining these two rotations. And so let's see if this works. Okay, press play. Gonna look around at some points. Let's pick that one. And then we modify the yaw offset. And now we can rotate the turret. Isn't that neat? And so then what happens if we flip these two? And then go back to Unity. So we look at that point. Now if we turn this one, it's going to rotate around the world space y-axis, right? You can see that this is the wrong axis. So we don't want to rotate around this one. And so the order of multiplication matters in rotations. It's a very, very important thing to remember. And it's a little bit unintuitive because this doesn't happen with normal numbers. Again, 5 times 2 is the same as 2 times 5. But if we're doing orientations, A times B is not the same thing as B times A. Okay. So that's the turret orientation. We can see if our input is now working. We're gonna make this private because we wanted to do this with a scroll wheel, right? So we're gonna want to clamp this too. Between maybe negative 90 to 90. Let's see if this works. Because quaternions are special. You know, there's quite a lot of things that are order dependent when it comes to operations like that. Yeah, there we go. So now I can use the scroll wheel to rotate the turret. So I can like adjust to however I want to place it, right? Isn't that useful if you're making a game like Team Fortress 2 and you want to place turrets and then you can adjust the placement? Isn't that neat? What a video game. We did it. We made a video game. We basically made Team Fortress 2. Okay. I went a little bit over time. Sorry about that. But I really wanted to go through all the way to the end. Can we get tower defense? Yes. Or Team Fortress 3. That's true. Okay. Just wish there was an easy way to draw those shapes in the game view. Guess I'll look into shapes. You should look into shapes. It's a very good plugin. All right. Any questions about that before we head off for lunch? Oh yeah, the thing about like for quaternions where like A times B is not the same thing as B times A. That's because it's non-commutative is the term for that, which is actually very common. Most, like a lot of operators work that way too. Like A minus B is not the same thing as B minus A, right? So plus and multiplication for numbers are commutative, but minus and division are not commutative for numbers, right? And so quite a lot of things are not commutative like that. So it's not a super unique property to quaternion multiplication specifically. Matrix multiplication works the same way. It also depends on the order. And so, yeah. All right. I think we're all clear. No questions before lunch. Since I went a little bit over time, do we want a shorter lunch, or should I start the lecture a little bit later and then run a little bit over time as a whole? Well, what do we prefer? Shortened lunch or shifted everything? Do you have any preferences? Normal length lunch, long lunch, shorter lunch. Have to take another nap. Okay. Okay. I guess we're doing long lunch. Okay, regular length lunch. Okay, I think we're going for lunch then. So we're resuming at 13:15, I believe, right? Yeah, it's about 12:15 right now. Yeah. Cool. I think that's it. Thank you all for joining. Finally done with all of the assignments. We did it. And then we're gonna look into some new things after lunch. Yeah. New things. That's exciting, isn't it? New concepts, new tools in your toolbox that are gonna be super useful. All right. So feel free to head off to lunch. I'm gonna stick around for a little bit longer in case YouTube has questions, but I think YouTube is pretty quiet today. It's not too active. How's YouTube? Are there any thoughts, questions? No thoughts. Head empty. Okay, cool. Then I will. I think we are ready for lunch. Thank you for the lecture. No problem. Hope it's informative. Okay, great. I think that's it. See you in 1 hour from now. Then we're gonna resume with, we're gonna talk about, what did I list? I feel like I had a list somewhere. Where's, I think it was here. Oh yeah, so we're gonna do interpolation. We're gonna talk about curves. We're gonna talk about time and curve manipulation in general, frame rate independence, and we're also gonna talk about point physics and trajectories. Yep, that's what we're gonna do after lunch. So if that's your jam, then that's what's gonna happen. And then on Friday, Friday is the special day where I have no plans, and Friday is just going to be based off of what my students want me to talk about. So it's going to be kind of like a grab bag of various topics that seem interesting to talk about, that people want to know about, and yeah, so that's going to be Friday. Yeah, so that's when we're probably going to talk about more esoteric stuff. hypothesis. I feel like a lot of people want to know a little bit more about imaginary units and the internals of quaternions, which is a little bit spooky, but you know, that's fine. Okay. Thank you all for joining. I'm gonna go have lunch. We're resuming in 1 hour from now. And I hope you all have a good lunch or whatever it is you're doing, or a good nap if you're napping. I think Judith is napping. Good luck with your nap, Judith. Make sure to set a timer. All right. Bye, everyone.